Okay, so this time, instead of finding the mean for a frequency distribution table, we're trying to find the median. Okay, so what we're going to do is we are going to use the formula that we talked about on the last slide right here, the position formula, to figure out where exactly our median is going to be. So I believe this is the same set of numbers that we had before. And remember, to figure out how many numbers we have, we add up the frequency. Remember, we add up the frequency, right? Okay, so we're going to add up the frequency, and there should be 151. So our position formula says we take the number of items we have, we add 1, and we divide by 2. And so 151 plus 1, and divide that by 2. Okay, so our median will be in the 76th position. Okay, it's not going to be 76. It's going to be in the 76th position. Okay. So remember, the first two numbers are 0, and then the next number is a 1, right here. Next number is a 1, and then the next three numbers are 2. So far, I've looked at the first 6 numbers, okay? So if I look at the 6th number, is that going to be the median? The 6th number, by the way, is still a 2. If I look at the 6th number, is that going to be the median? No. Okay, so I haven't gone far enough in the table. So now I have 12 threes. Okay, so now if I look at so I've got 6. I've already looked at 6, and I've got 12 more. So now I'm in the 18th, looking at the 18th number. My 18th number is a 3. So have I gone far enough? No, I'm looking for the 76th number. So now I look at my 16 fours, right? I've got 16 more numbers. Okay, so now I'm at what? 34, I believe. Okay, so my 34th number is a 4. Still haven't gone far enough because I'm looking for my 76th number. So now I've got 18 fives. All right, so now I've got 18 more numbers that I am looking at. And offhand, I can't do 34 plus 18. 34 plus 18. And so now I'm at the 52nd number. My 52nd number is a 5. Still not far enough. 13 more numbers. And so my 65th number is a 6. Still not far enough. So now I'm going to add 31 more 7s. So I've got 31 more numbers and 96. There you go. Okay, so my 65th number was a 6. My 66th number, the next number, is a 7. And my 67th is my 68, my 69th, my 70th, 71st, 72nd. So notice that in here, in my 31 sevens, I hit the 76th number. So my median is going to be 7, okay, because I hit my 76th number between 6 and 7. Does that make sense? I hope that makes sense. So 76th position, we count. So we've got my first two numbers are 0s. My third number is a 1. My 4th, 5th, and 6th number are 2s. 7th, 8th, 9th, all the way up through the 18th number is a 3. All the way up to the 34th number is a 4. And here we go. When we hit our 7s, we've got our 66, 67, 68, 69, 70, 71, 72, 73, 76. That's the number we're looking for. So my 76th number was a 7. Oh, there we go. So why would we look at the median and the mean? Why would we do both Why not one or the other? Everybody's like, oh yeah, well, let's find the average. Well, here is an example of when the mean doesn't really give us the full picture. So this is an example of why we would look at the median maybe more than the mean. If we have 5 people working at a manufacturing plant, they have salaries of $19,000, $20,000, $21,000, $22,000, $23,000, and then we also have a manager who makes $95,000. We've got 6 different people. Okay, total. Okay, so if I want to find the median, by the way, when we do measures of central tendency, what we're trying to figure out is kind of how the average dude or dudette, the average person, what's happening with them, okay? Measures of central tendency kind of tell us the middle, right? So the mean is supposed to measure the middle, how the average person gets paid in this particular example. We're going to see that it really doesn't give us a good idea of how the average person gets paid, and the median in this case is actually a little bit better. So we find the median, we put our numbers in order, which they are, and since we have 6 numbers, we are going to add the middle 2 numbers and divide by 2. So we need our 21.5, our 22.6. And we're going to add those and divide by 2. That will give us the median, So 21.5, 22.6, add those together and divide by 2, which will give me 22,050. All right, so, and that, yeah, that sounds about right. If we look at all of our salaries, you would expect the average person to get paid about $22,000. Some people make less, some people make a little bit more, but yeah, 22,000 is about right. On the other hand, if we look at the mean, so the mean, remember, we're going to add up all of our salaries. We're going to take 19.7, 24, add these up, and divide by 6. Okay, I'm going to cheat here. So we're going to add those numbers up. We're going to divide by 6, and you see that the mean is 33,700. That doesn't represent anybody. So what happened? Why is this so far outside of what's really happening with kind of like the average person? And it's because of the, we call it an outlier, actually. It's because of this guy right here. This 95,000 is way, way, way outside of what the rest of the people are making. And so it artificially inflates the mean so that it doesn't really represent anybody. So that's why you can have, so if you have a number that's way, way outside of kind of the normal range, it artificially will raise or lower the mean, and the median then would be the best thing to look at to see what's really going on. All right, mode. Mode is what happens most often. So mode is the most. Okay, so we're looking for the highest repeat. Okay, if there's no repeated items, then we say that the data set has no mode. We can actually talk about, so let's suppose that there are 7 of the 6s, 7 6s, and then there are 7 of the 9s, but there's only 4 of the 2s and 9 of the 10s, whatever. Okay, so notice I have the same number of 6s as I do 9s. When we have this situation where we have an equal number like this, we call it bimodal. There's actually 2 modes. call it bimodal. Had we had 7 tens, we would call it trimodal. There's actually 3. To be honest, I don't think you're going to have to worry about it in this class, but if you ever see this word, that's what they're talking about, is when whatever happens most often, there's 2 items that happen the same amount of times that are the most often. Okay, so find the mode. All right, so I've got 2 7s and nobody else repeats. So my mode would be 7. Mid-range. Mid-range, we take the lowest and the highest, we add them up and divide by 2. Lowest plus the highest, divide by 2. Newsweek, examine factors that affect women's lives, including justice, health, education, economics, politics. Graded each of the 165 countries on a scale from 0 to 100. The 12 best places to be a woman and the 12 worst places to be a woman are shown below. Find the mid-range among the 12 best countries. So we take the highest, we add the lowest, and we divide by 2. Worst places and best places. All right, so we're going to take the highest, which is 100, and we're going to take the lowest. We're talking about, again, we're amongst the best places. Okay, we're ignoring the worst places for this question. And the worst place is France. It's not the worst place, it's the lowest of the best place. And we're going to add those up and divide by 2. So 100, we're going to add 87.2, and we're going to divide that by 2, and we get 93.6 for the mid-range. By the way, I do want to point out this study was done by Newsweek, which is an American company. So maybe the people that live in Chad, for example, might have a different view of it being the worst place to be a woman. So this is definitely skewed by the fact that the study was done in the United States. So that's something to be aware of when you're looking at data. Let's see. And 93.6 is the mid-range. And that's it.